We present CEDAR, a human-inspired localization approach that uses semantic landmarks in place of range sensors. Traditional Monte Carlo localization approaches operate by performing range-based scan matching from LiDAR to a pre-existing map. More recent approaches can use a depth image to simulate a LiDAR scanner. CEDAR proposes to use deep learning-based semantic segmentation of RGB images to both replace and enhance range-based scans. This means our approach is able to localize using RGB images only. CEDAR does this by creating a semantic scan which consists of label and bearing tuples. Optionally, depth information can be added to increase performance. The semantic information present in floor plans is also used. Instead of using binary occupancy maps, CEDAR proposes to use semantically labeled floor plans. The semantic scan and floor plans are used within a distance map framework. Also known as likelihood fields, these maps represent the distance to the nearest occupied cell. Additional label-specific maps are also computed. During runtime, these maps are used to estimate the likelihood of each Monte Carlo pose hypothesis. Our experiments show that CEDAR can perform global localization quickly and efficiently. When provided with depth measurements, CEDAR can outperform the state-of-the-art. In the absence of depth measurements, the performance is still comparable. CEDAR can also perform room-level initialization. We show that our approach can converge faster than competing methods. Qualitatively, it can be seen that the semantic segmentation closely resembles the 3D world. The semantic scan is also closely aligned to doors and other semantic elements. It can also be seen that the semantic information allows CEDAR to perform long-term tracking in cluttered environments. In conclusion, CEDAR fundamentally changes the way Monte Carlo localization operates. Instead of using expensive range sensors that produce a large amount of data, robots can now use cheap cameras and a small number of semantic landmarks. More importantly, this level of biologically inspired perception opens new directions for the field. Thank you for watching.